Good evening, students. Welcome back to my channel, Orion Academy of Sciences. In the previous class, I've taught about electric charges and fields, which I introduced about the basic parts. So today, I will go on with the chapter, the second part, that is insulators and conductors, and I will try to complete the Gauss's law and applications as well today, if possible. Okay, for that you need to take a rough book and a pen along with you so that you can write it down what I am writing out on the board. So please focus and let's start the class. So, electric charges and fields. Let's start. Electric charges and fields. What we will be studying about today, that is methods of charging. First point, today we will be studying out methods of charging. First of all, before starting methods of charging, first we need to know what are conductors and insulators. What are they actually? The conductors are the substances through which electric charges can flow easily. They are known as conductors. For example, we can give metals, graphite, acids, human bodies and animal bodies. These are the great examples of conductors. And what are insulators? The substances through which electric current cannot flow easily are called insulators. Give example if asked, then you will tell glass, diamond, porcelain, plastic, nylon, wood, mica, etc. That's all these examples. So let's write it down. Conductors. What are conductors? The substances through which electric current can flow easily, or electric charges. Anything you can feel like you can write. Electric charges can flow easily are called conductors. Give examples. Please write it down what I am writing it on the board. Please write it down in your rough book so that when you revise you can recapitulate in it in your mind. Okay, metals, graphite, acids, human and animal bodies. Now, what are insulators? I've already told you that the substances through which electric charges cannot flow easily are called insulators. If asked examples, then glass, diamond, porcelain, plastic. I'm writing it down. Please note it down. If you don't understand the basics, then you won't be able to continue properly with the chapter. For that, you need to see my first part of the video, okay? The substances through which electric charges cannot flow easily are called insulators. Example, glass, diamond, porcelain, etc, etc, anything. We can see these three kinds of examples. Plastic. Acha, please tell me in the comments if is plastic an insulator or conductor. Okay, I know many of you already know the answer, but please write it down so that I can understand whether you have studied the chapter or not. Okay, so conductors and insulators we have completed. Now we come to the part that is methods of charging. For that, please write it down. First of all, I will wait for some moments and then I will rub it down. Mainly, before continuing it, there are three methods of charging a body. What are the three methods of charging a body? That is charging by rubbing or friction, charging by contact or conduction, charging by induction. These are the three steps for methods of charging. Now, friction you already know that by rubbing you can get a charge. We will come with the examples. One practical example is rubbing our hair with a plastic scale, okay, on dry hair, and then you put your scale on some bits of pieces of paper and they will get attached to it. They will get attracted to it because they get a charge. They create a charge under themselves, okay. Now charge by contact or conduction is an uncharged body kept in front of charged body. What will happen? Both will get into an equilibrium. Either it will get a positive charge or either it will get a negative charge depending upon the situation. And the last is by induction. Induction is totally a different concept, but before that I'm rubbing it down. We are coming to the first point. First is charging by rubbing or friction. So what we will learn, that when two bodies are rubbed together, what happens? Two bodies are rubbed together. They are rubbed. Then what will happen? Some electrons, there are electrons. Some electrons from one body get transferred to the another body. Now what will happen? The positive and negative charges appears in the bodies in equal amount. Positive charges and negative charges will be present on the bodies in equal amounts. Why? Due to the transfer of electrons. Now you will ask, sir, is there simultaneous transfer of electrons means between both of them? Yes, it can happen. Okay. Now the body that donates the electrons becomes positively charged. We have already known in chemistry that the substances which donates electrons are positively charged and which gains electrons becomes negatively charged. It's as simple as that. Now let's write it down. Okay, please write down the points which I am noting it down on the board. First point. Okay, this one I can write it down as A. First point, Roman numerals, it will be better. When two bodies are rubbed against each other, some electrons are transferred from one body to another. Okay. Achha, we are it's getting a little bit tilted, so just wait for some moments. I will write it down straight. so that you can understand. Okay, the positive and negative charges on the body appears in equal amount due to transfer of electrons. Now, what is that? The body that donates appears in equal amount simultaneously. We write it simultaneously. Okay. Now, third point. The body that donates electrons becomes positively charged. The body that donates, okay, this is creating a ruckus, whatever, that donates electrons becomes positively charged. Good. Positively charged. What is the next point? Simple. The body that gains electrons becomes negatively charged. Simple. So, what is telling? Rubbed. Okay. Don't think it is a rubber. Okay. Now, some electrons are transferred from one body to another. The positive and negative charges on the body appears in equal amounts simultaneously due to the transfer of electrons. If they do not appear in equal amounts, then they will not be in equilibrium. Not be in a state of equilibrium. Okay. They will not be in a state of equilibrium. And the last point is body that donates electrons becomes positively charged and gains electrons becomes negatively charged. Now we will come forward with the example. I think so you can clearly see the board and you have written it down as well. So let's rub. Okay, I am rubbing the first 2 points so that I can write the example. I hope so you will be able to understand this handwriting, because it will create a problem for your eyes. I think so. Now, what is the example? When a glass rod is rubbed with a silk cloth, the glass rod acquires some positive charge by losing electrons, and the silk cloth acquires negative charge of the same amount by gaining electrons. See, I'm just drawing it, okay? Then I will write down the point. See, this is a glass rod, okay? Understand, this is a glass rod. So it is rubbed with a, let's suppose say silk cloth. This is already given. Silk cloth. What it is done? Rubbing. See, rubbing. So this thing, it is giving electrons. What it is doing? See. Excuse me again. Just a little bit. A rod. Okay. So this thing is donating the electrons and acquiring the positive charge, and this thing is also donating electrons. This thing is gaining electrons. See, gaining electrons, then it will become negatively charged. Okay, so now let's write down the point. Achha, and rubbing is this double as well. When a glass rod is rubbed with a silk cloth, what happens? The glass rod acquires some positive charge. I am writing it in short form, positive charge, by donating electrons. By donating electrons, and the silk cloth acquires, and the silk cloth acquires same amount of negative charge, by gaining electrons. Okay, this is a great example of charging by rubbing or friction. Okay, we have studied this in previous classes as well, but this example is a continuous thing. It is coming every time. Why? Gaining electrons. Very good. Another example, ammonite rod and wool cloth. What will happen? Ammonite rod on rubbing with wool cloth becomes positively charged, making the wool cloth negatively charged. Same example, just here in case of glass, it is put ammonite, and here in case of silk, it is put wool. Similarly, what will happen? It has acquired positive charge and it has acquired negative charge. How? By rubbing or friction. Simple, by rubbing or friction. So the first point comes to an end, and I think so you all have understood. If there is any problem, you can ask me in the comment section. Now the second point. What is the second point? Charging by contact or conduction. For this I need to rub it down. Okay, you can stop the video and see it properly. What is written down on the board? When a glass rod is rubbed with a silk cloth, the glass rod acquires some positive charge by donating electrons, and the silk cloth acquires same amount of negative charge simultaneously. Why I am not writing it down, I don't know. But when it is donating electrons, simultaneously it is also acquiring electrons. Okay, by gaining electrons. And ammonite rod, here you can write down the same statement. How? When a ammonite rod is rubbed with a wool cloth, the ammonite rod acquires some positive charge by donating electrons, and the wool cloth acquires same amount of negative charge simultaneously by gaining electrons or acquiring electrons. These two are great examples of charging by rubbing or friction. We need to understand it. Okay. Now the second point comes. First I will give one diagram and then I will write down the point for this particular case. Okay, charging by contact or conduction. See the diagram properly. See, this is a charged body. Okay. These are all positive charges, and this one is an uncharged body. I will write it down for your help. This one is uncharged, and this one is charged. Hey, sorry, I'm mistaken it. Sorry for this problem. Uncharged one. Okay. Now, see, it is brought into contact. I will write it over here. Brought into contact. Now, if it is brought into contact, then what will happen? They both will have positive charges around it. See, this is a great example. Okay. Diagrammatic explanation. Best. Sorry for the diagram, but please see. Both becomes positively charged. Great example. Great. Charged by contact or conduction. Now here we come with the point. No. So here what is? We take two conductors over here. One is charged and the other one is uncharged. Good. Now we need to bring this in contact. See, I have written in down. Brought into contact with each other. What will happen? The charge with the positive, it can be positive or negative, it doesn't depend. Okay, just showing it down. This one is for positively charged, another one I am showing. Again I am see this negative, and this one is uncharged. Okay, brought into contact, both becomes negatively charged. Okay, please note it down, please guys. I mean students, anything I can call you. See, so the charge, whether positive or negative, under its own repulsion will spread over both the conductors. See, conductors, if I remove this conduction, then means conductors. It will happen only in case of conductors, not in case of insulators. So, will spread over both the conductors. Thus, the conductors will be charged with the same sign. This is called as charging by conduction. So, will I write down the points for your help? Okay, I am writing it down. Just you can frame it yourself also. Take two conductors. One charged and other uncharged. Now, a second point. What is the second point? Both the conductors both the conductors, both the sorry, both the conductors are brought into contact. Now, what will happen? With each other. Now, what will happen? Same. The charge, whether negative or positive, under its own repulsion, will spread over both the conductors. The charge positive or negative will spread over both array. See, will spread over both the conductors. The conductors. Okay. Under its own repulsion. Its own repulsion. Done. Simple statements. You just need to remember it. Is the second point. Charging by conductor conduction. See, positive charged, uncharged. What will happen? Both becomes positively charged. Negatively charged, uncharged. Both becomes negatively charged. Okay. So simple. Just take two conductors, one charged and the other uncharged, and bring both the conductors in contact with each other. Now, the charge, any charge, is spread over both the conductors under its own repulsion. Okay, clear? So, charging by conductor conduction is over. Now, I am coming with the last method of charging, that is charging by induction. Please understand it properly because it's a depthful concept. You need to understand it properly. Okay, please follow it. After that we will come with the numericals. Okay, of what? Coulomb's law. Now we will come with Coulomb's law after this. It's an interesting concept. Just you need to properly see all my videos and you will understand how easy the chapter is. I mean, you can easily solve within seconds. Physics is all about understanding the concepts properly and then revising the formulas and putting the formulas in the questions. In the numericals, okay, and you need to also know all the derivations. If you properly know all the derivations, then it will be pretty easy for you. So now the point comes. Okay, charging by induction, but before that I have left one point for conduction. That is, please note it down. This is an important point, and from this concept or point, questions can arise. Okay, so what is that point? If two conducting spheres of radii R1 and R2 and initial charges, what are the initial charges? Q1 and Q2. Simple. Initial charges Q1 and Q2 are brought into conduction. I mean induction, conduction, not induction. Okay, just I am writing it down. Contact, conduct, anything you can say, but better would be contact, conduct, conduction. Okay, initial charges. Then what will happen? Their final charges after conduction. Their final charges after conduction, Q1 dash and Q2 dash will be okay. This one is not 7. Okay, this was a comma. So how will we write it down? Will be Q1 is equals to R1 by Q total by R total. Simple. Q total by R total. And how will you find out Q2? Q2, Q2 dash, sorry. R2 is equals to Q total by R total. What is that? Therefore, the answer will be Q1 dash by Q2 dash. Q1 dash by Q2 dash is equals to R1 by R2. End of the concept. This one is very important for your exams. It might come. I'm not telling that it will come, but it might come. There is a possibility. Okay. What to say? ICAC 2027 or CBSE 2027. It will come. These questions will come. Okay. Two conducting spheres of radii R1 and R2 and initial charges Q1 and Q2. Okay. If they are brought into contact, see, just see R1 and this one is Q1. Okay. R2 and this one is Q2 brought into contact, then you will get this one. Okay. Yeah, plus. Now I am giving you one question to answer, that is, if there are two conducting spheres of radii, question, okay, please write it down in the comment section. R1 is 20 centimeter, R1 is 20 centimeter, Q1 is 3 and R2 is equals to 40 centimeter and Q2 is equals to 2. Then what will be the answer? Okay. And second concept, not second question. If this one is positive and this one is negative, what will happen between them if they are brought into contact? Find over here Q1 dash by Q2 dash. Okay. Fine. So I think so you have properly understood this portion. Now we will continue with the charging by induction. Charging by induction. Now, a pretty good concept to come. That is, if a charged body is brought near an uncharged body, then one side of neutral body closer to the charged body becomes oppositely charged, while the other side becomes similarly charged. Okay, what is the point? Point is telling, if a charged body is brought near an uncharged body is brought near an uncharged body, then one side of neutral body close to the or closer to the charged body, closer to the charged body becomes oppositely charged. I will show you with the help of a diagram, okay? But first, please write down the point. Closer to the charged body becomes oppositely charged. Oppositely charged, and other side of the neutral body and the other side becomes similarly charged, and the other side becomes similarly charged. Okay, so here we come with the diagrammatic explanation. See, please see. I'm using these two pin colors so that you can understand. See, okay, see properly. So here it is plus Q. I mean, okay, plus 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 plus. Now here it is on the both sides. Please see. Minus, 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 and again over here plus, 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 plus. Now, see please. Now this conducting sphere is connected to the earth. Now you will ask me, sir, why? Why it is connected to the earth? Let's see why it is connected to the earth. Again plus Q plus 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 plus. Another color pin would be better, much more. Another color, so that I can make you understand that it is connected to the earth. But okay, for today, please see like this. I will from next day bring on another color. See with the help of this color. Okay. What do we call this? It is called earthing. Ball is connected to the earth, or conducting sphere is connected to earth. Now what will happen? See, now comes the magic. Again we need to draw plus Q, that is plus 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 plus. Now the circle again, minus 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 minus. minus, 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 minus. Now, you will ask me, sir, where did the positive charge go from the ball? Very simple, brother. See, connected to the earth. That means it is going to the earth. Now we can write it down. Positive charge goes into the ground. Into the ground. Really good. Now, what will happen? Last tip. It will totally get negative. See. Because remaining charge on the ball is uniformly distributed. Simple. Remaining charge on the ball is if there is any background noise, please ignore it. Okay, I will try to cut it down from this, but please is uniformly distributed. Just please understand what I am trying to say. Okay, see, first we take a conducting sphere, minus charge on one side and positive charge on the other side, plus charge, sorry. And here we take this conducting rod. Okay. Now, see, we connect it to the earth through earthing. Please write down this point, through earthing. Just missed out this point. See, let me. After I complete this chapter, I will give you a one shot as well. So that means a summary, so that you can understand that how deeply I have studied the chapter and how will I complete it within a jiffy, means in a one shot video. It will take around 2 to 3 hours. Okay, just understand it properly, and you can write down the short notes from there, but please write it down as well, because it will be more helpful in the long run. So this is our thing. So it is connected to the earth, and the positive charge, what happens, it goes into the ground and still it is there. After it is removed, we will see that the negative charge is placed all throughout the conducting sphere. Simple as that. Means what is happening over here? Simple. What is happening over here? Charging is done without actually touching the bodies, without actual contact of bodies. So, properly clear everything. Now I will rub it down and mention all the important points of induction that you need to know. After this, we will come with Coulomb's law. Now, important points regarding induction. See, okay. important points of regarding induction. 110 points. Please note it down. In case of metals, induced charge is equal and opposite of inducing charge. What is that? IQ induced is equals to minus Q inducing. Metals, in case of metals, see, for metals this is the concept. Metals, first point, it is about metals. Metals, what happens? Q induced is equals to minus of Q inducing. Please, these are important. Again I am repeating, induced charge is always equals to the opposite of inducing charge. Okay. Now for other bodies, Q induced is equals to Q inducing bracket, second bracket, 1 minus 1 by epsilon ER. Now, third point, induction doesn't take place in point masses. Induction doesn't take place point masses. It always take in case of charged bodies. Okay. Now, net electrostatic force between inducing and induced bodies always attractive. Net electrostatic force between inducing and induced body is always attractive. Between inducing and induced bodies is always attractive. Okay. These are simple points, but you need to remember it as well. Now, the last point. What is it? Repulsion is the sure test of electrification. Please remember this point. Repulsion is the surest test of electrification. Is the sure test of electrification. Done. Why? Now you will ask me, sir, why? Why it is the surest test of electrification? Because attraction can happen in opposite charges and between a charged body and an uncharged body. So repulsion is the attraction can happen anywhere. It can happen between opposite bodies with oppositely charged bodies, or it can happen in case of charged body and uncharged body. But in repulsion, it's totally a different concept. Like and like charges, what happens? Like and like charges repel each other. Simple. Charged body repel each other. Uncharged body repel each other. Simple. Charged body having different charges, means positive, negative, then it will get attracted. But positive, it will never attract. Negative, it will never attract. And uncharged, it will never. Means neutron, it will never attract. So these are the important points of induction. Now, there is a myth we always know. What is a myth about? That myth is about induction produces equal and opposite charge. It is a myth. Not a truth. What is actually the truth? Induction produces equal and opposite charges only on metallic objects. And for non-metallic objects, induced charge is always lesser than the inducing charge. This one is for metals. See, for metals it produces equal and opposite charge. And in case of non-metals, see another point it arrives. See how many points? 1, 2, 3, 4, 5, 6 points. Non-metals. Q induced is always less than Q inducing. See another very much important point. Here we complete this portion of charging. Okay, means methods of charging completed. Now we will continue with the Coulomb's law. Now we will start with the Coulomb's law, and we will understand what is Coulomb's law. Okay. So Coulomb's law. Let's start. Okay, today I think I will be able to complete with the Coulomb's law, because if I continue, then it will never end. Okay. Many examples will be dealt later, but today first we'll just understand Coulomb's law and Coulomb's law in vector form, and we end the class today. So, Coulomb's law. So, what is Coulomb's law? Now, Coulomb's law is a quantitative statement about the force between 2 point charges, which is derived using the torsion balance experiment. First point, quantitative statement. Quantitative statement of force between 2 point charges, about force between 2 point charges, which he derived using the torsion balance experiment. I will be also bringing shorts about some concepts for this torsion balance experiment. I will deal you it in shorts, okay? So please see the shorts as well from my channel, which is derived using the torsion balance experiment. Now, what is the statement? What is the statement? The statement is the force of interaction between any 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So, please write down the point. The force of interaction between 2 point charges, interaction. This is the first point. This is the second point. The force of interaction between 2 point charges Q1 and 2 point charges Q1 and Q2. I don't need to write. 2 point charges is directly proportional. Directly proportional to the product of charges, and inversely proportional to the square of distance between them, and inversely proportional to the square of distance, square of distance between them. Good point. See, this is the main statement. Okay, if you are given to write in the exam a defined Coulomb's law, then you will write the force of interaction between 2 point charges Q1 and Q2. You can mention it. Okay, there will be no problem as such. Is directly proportional to the product of charges, means you will write dot product. Okay, is directly proportional to the dot product of charges and inversely proportional to the square of distance, means r square, between them. This is the main point. Now we come with the main thing, that is the formula. Okay, but just remember, the force is repulsive if the charges are the same signs and attractive if the charges have opposite signs. Similarly dealt beforehand. So let's just make you understand. Okay, after this I will end the class, but before that please see, please understand properly what I have taught you today. Please understand properly. If there is any doubt, write it down in the comment box. I will try to explain it through shorts or through posts or through comments in the YouTube section. Okay, but please understand, Q2, Q1, this one is in case of vacuum. Now two charges are separated by a distance r. Now what is the formula? K Q1 Q2 by r square. What is K over here? K is actually the constant. K is equals to 1 by 4 pi epsilon naught. Now what is called epsilon naught? It is called the permittivity of free space. See, permittivity of free space. What is this permittivity of free space? What is this epsilon naught? It is the permittivity of free space. And what is the formula? What is the value for epsilon naught? 8.854 into 10 to the power minus 12 Coulomb square by Newton meter square. 8.854 into 10 to the power minus 12 Coulomb square Newton inverse meter square inverse, or Newton meter square, whatever. And what do we take it for all practical purposes? This value 1 by 4 pi epsilon naught, we can take it as 9 into 10 to the power 9, 9 into 10 to the power 9 Newton meter square Coulomb inverse square. Simple. Simple. Coulomb's law is very simple. Just remember this law statement that the force of interaction between 2 point charges Q1 and Q2, see, Q1 and Q2 is directly proportional to the dot product. You don't need to write. Okay, it will come in hard. Product of charges Q1 and Q2, Q1 into Q2. See, Q1 into Q2, and inversely proportional to the square of distance between them. Okay, so if asked, see, directly proportional means Q1 into Q2. That means if this increases, this will also increase, and if this decreases, this will also decrease. But in case of inversely proportional 1 by r square, if this increases, this will decrease, but if this increases, this will decrease. And K, what is K? This K is a constant. And what is the constant's formula? 1 by 4 pi epsilon naught. What is this epsilon naught? It is called the permittivity of free space. What is the value of epsilon naught? It is 8.854 into 10 to the minus 12 Coulomb square slash Newton meter square. Let's not write like this, okay. And for all practical purposes mainly, what we will take it over here, 9 into 10 to the power 9 Newton meter square Coulomb inverse square, or by c square. Done. This Coulomb's law. Today we have got a brief introduction about it. On the next class we will deal with the Coulomb's law in vectors form, important points regarding Coulomb's law and applications of Coulomb's law through numericals and examples. Up till then, please revise all the points that I have written down on the board. If there is any problem, any doubt arises in your mind, please write it down in the comment section and I will try to improve it, or I will try to clear your doubt as soon as I get the response. Till then, bye and thank you.